Hello everyone. In the last lecture, we saw one example of a group. In today's lecture, we will look at yet another example of a group. And in this, we have a nice combination of addition as well as multiplication operation. So let's look at the example. Firstly, the set that we have is q minus of minus 1. Let's understand this set. It contains all rational numbers except minus 1. So for some reason minus 1 has been removed from the set. So you will find all your other rational numbers here except minus 1. So when I take an element in this set, two things will follow. It is a rational number and it is not equal to minus 1. And on this set, we have defined an operation as a star b equal to sum of the two elements plus product of the two elements. So once again, just to illustrate this operation, let's look at what would be 2 star 3. 2 star 3 would be sum of the two elements plus product of the two elements. So this will be 5 plus 6, that is 11. So with this operation, I would like to prove that the given set becomes a group, and group means I need to prove that it is a binary operation. I need to prove the associative property, existence of identity, as well as existence of inverse for every element from the given set. And at the end, I also need to answer the question whether this group is abelian. That means I need to verify if the commutative property is satisfied. But let's first begin with the closure property, as we say, or proving that star is a binary operation. Remember the technique. We start with two arbitrary elements of our set, and we will have to prove that when we combine these two elements with the operation star, the resulting element is again in the same set. So at the end of this step, I would like to prove that a star b is again an element of the set q minus of minus 1. But firstly, remember what I had told you. When I say that two elements belong to this set, it will mean that both elements are rationals, but neither element can be equal to minus 1 because minus 1 has been removed from this set. So if I take two elements in this set, they'll both be rationals and they'll both have to be different from minus 1. Now let's look at the definition of a star b. A star b is a plus b plus a into b. Since both a and b are rational numbers, their sum is a rational number, their product is a rational number. So this combination ultimately gives me a rational number. So it's fairly clear because addition of two rational numbers is a rational number, product of two rational numbers is a rational number. This element a star b is definitely a rational number. But that's not my set. I need to prove more importantly that a star b cannot be equal to minus 1. So let me find out. I need to prove it is not equal to minus 1. In many cases where it is a little difficult to prove something directly, we use the method of contradiction and see what happens. So since I want to prove that a star b is not minus 1, let me actually find out what will happen if a star b does become equal to minus 1. So suppose in some case a star b does actually become equal to minus 1. Now I need to find out, so I need to come up with some kind of a contradiction. That's the intention. But for the moment, let me simplify. Substitute for a star b. A star b is a plus b plus ab. That should be equal to minus 1. Let me take 1 on this side. So I'll get a plus b plus ab plus 1 equal to 0. So let me put these two elements together, and from the second and the third element, let me take b common. One plus a or a plus 1 is the same thing, so I can take that as a common factor. 1 plus a into 1 plus b is equal to 0. Now remember, we are dealing with numbers. So if the product of two rational numbers is 0, one of them has to be 0. So this will mean that 1 plus A is equal to 0 or 1 plus B has to be equal to 0. But come back to what we know about A and B. We said right at the beginning that A cannot be equal to minus 1, and if A is not equal to minus 1, take minus 1 this side. There is no way 1 plus A can be equal to 0. And same is the story with B. Since B is not equal to minus 1, 1 plus B cannot be equal to 0. So neither of these cases is possible, and therefore A star B simply cannot be equal to minus 1. So if I assume that A star B is minus 1, I end up with a contradiction. Either this has to be 0 or this has to be 0, but I know that neither of the cases is possible, and therefore A star B cannot be equal to minus 1. So this tells me two things. A star B is a rational number and it is not equal to minus 1. Therefore, A star B is a rational number other than minus 1. It's any other rational number except minus 1. So it belongs to our set, and therefore closure property is satisfied, or star is a binary operation on the set. Next, we would like to prove that this operation is associative. Like we did in the earlier lecture, to prove the associative property, we always start with 3 elements of the set. So let us begin with 3 elements in the given set, and let me find out what is A star bracket B star C. So let me evaluate this expression by first putting the brackets for B and C. So this will be A star. Now B star C is sum of the 2 elements plus the product. So B star C is B plus C plus BC. Now I want you to think of the whole bracket as our second element. So A star, this element. So it will be first element plus the second plus product of the 2. So it will be first element plus the second. Our second element is that entire expression in the bracket. So it is first plus the second plus product of the 2 elements. So if I simplify, I'll get A plus B plus C plus BC plus AB plus AC plus ABC. What I want you all to do is to figure out what will be A star B star C. So what will happen if I put the brackets for A and B? Pause the video, do your calculations, and then come back to the video and check whether you get the same expression as whatever I write. So you'll notice that you get the same thing. You will have to probably rearrange some of the terms, but you will get precisely the same expression as the above, and that tells us that this A star bracket B star C is the same as bracket A star B star C. So it doesn't matter where I put the brackets, and therefore the associative property is satisfied. So we are done with closure property, we are done with the associative property. Now let's come to the existence of identity. Recall what I did in yesterday's problem. We do not want to tax our brains, so I do not want to take a guess as to what will be the identity. So there is a mechanical way out which we saw in the earlier lecture, and that is you assume, let if possible, E, B identity in this set with respect to the given operation. So we will assume that some element E is identity, and then we will go through the motions, and we'll find out what could be the possible value of E. So if at all E is going to be my identity, what are my expectations from E? I would want A star E to be always equal to A for all elements in the set. Let's simplify this equation. A star E is A plus First element plus the second plus the product of the two, and that should be equal to A for all elements in the set. Let's simplify this some more. Since A is an addition, there is no harm in doing this. You can cancel A from both sides. You will get E plus A into E equal to 0. And that means E into 1 plus A is equal to 0. And now be careful. I have to prove that this is satisfied for all elements in the set. Now when I say A is in this set, I know that A is not equal to minus 1. That means 1 plus A cannot be equal to 0. And since it is not equal to 0, it is perfectly okay for me to take it on the other side. And I can claim, so if 1 plus A is not 0, E has to be equal to 0. But finally, before you say that this is indeed the identity, please make sure that it belongs to our set. It is a rational number and it is not equal to minus 1. So definitely this element is going to be my identity. So identity is 0. And now let's go to the final property of a group, namely inverse for an element. So we begin once again with an arbitrary element of the set. Remember, once again, this will mean two things. A is a rational number. A is not equal to minus 1. And then that means, let me put that to the side. So 1 plus A cannot be equal to 0. Again, like I did for the identity, I do not want to tax my brain. So I will use the same mechanical method. Let, if possible, B be inverse of A. And then from our expectations of B, we will write out an equation. We will solve that and we will find B. So if B is going to be inverse of A, then I want A star B to be equal to E. In the last step I proved that E is 0, so I will substitute. Also let me substitute for A star B. So I will get A plus B plus AB equal to 0. And this will mean B plus AB. Remember, I am trying to find the value of B. So I need to basically isolate B, have B on one side and take everything else to the other side. So B into 1 plus A is minus A. And therefore B is equal to minus A upon, stop for a moment, because I need to push this in the denominator. But before I do that, I need to make sure it is not equal to 0. But here, I know that it is not equal to 0. So I can safely take this in the denominator. So if at all B is going to be inverse of A, B will have to be equal to this. So what is preventing us from calling this as inverse of A? We are still one step away from the answer. Remember, if this is going to be inverse of A, it's very important that this also belongs to our set. So let us check whether this element belongs to our set. B is one rational number divided by another, so it's clear that it is a rational number. What is not clear is that it cannot be equal to minus 1. So let us check whether what would happen if it would be equal to minus 1. If B would be equal to minus 1, then I'll get minus A upon 1 plus A equal to minus 1. And I will get A equal to 1 plus A, which would lead to an absurdity like 0 equal to 1. You know, that's not possible, and therefore this is not possible. So B cannot be minus 1, and therefore our element B does belong to the set. So this becomes inverse of A, and therefore every element has an inverse. You can also verify that it is abelian. All you need to do is to prove that A star B is equal to B star A. That will be all for today. Thank you.